Let me try now and capture what you just saw in terms of distilling the essence of the concepts. Back to the equation. Now you have a better idea that there are many variables, and all the variables related to the operator, to the input, the pertinent variable, not the input, the environment, the apparatus per se and its own variables, the variation in the distance depends on the variation on these x's. The variation in what you get depends on the variation of what you do, and on the variation of the context in which you do it. Some of these variables are controllable, some are uncontrollable, many are partially controllable. What do you do with an uncontrollable variable? You can't control the variable, but you can control for it. If you're sailing, you don't control the wind, but you do control the angle, the tension in the sail. You control the angle. You control a number of variables for which you can adjust as a function of the uncontrollable variable. Now, as you just saw, some of those are trivial, color, happy face, and thus are unlikely to have a big impact here. They are trivial. And if we work with 50 variables, we'll get lost, simply. First step in improvement is isolating the vital few variable and not wasting any time with the trivial many. With data, evidence-based diagnostic. So, you remember in the exercise, when the catapult was moving, we of course inferred that location was important. We could infer that because logic tells us that it is, and because we observed that when we move it, indeed, in accordance with logic, it goes further. We move it back, it goes not quite as far. Having isolated vital few variables, we can order them here in order of priority and have a Pareto diagram, meaning 80-20. Isolate the vital few up here. That's a Pareto diagram. You may refer to it if you're not familiar with it. Go to Wikipedia. Always a good reference. Once you got this, you are through in DMAIC in terms of an improvement methodology. You've analyzed. You've got measurement system, you've got data. Now you've formulated a diagnostic. You're ready to improve and to reduce variation in a critical variable. And for this, in the improvement phase, you'll generate a simple device, which was a clamp, very simply, in the example I used. And if you apply that device, which a Poka-yoke simple device to reduce variation in a critical variable, fail-safe if you like, idiot-proof if you don't mind. So as you reduce variation here in a critical variable, you would expect variation over there to be reduced. Now this diagram here, this is the voice of the customer, value inside, no value outside. And what you realize is that variation is the enemy of value. More variation, less value. But variation is our friend as we want to improve. If we measure the variation here and we measure the variation there and we observe, we can correlate. Easy on a catapult. More complex if you're looking at a legal defense case, at a surgery, or at designing a complex building. All right? So, having done this, what you've done is reduced variation. You've created more value, and that is measured by a reduction in the variation, is a reduction in the sigma here, and you've got 6 on each side. And whoops, once you've got this, the idea is to control the process now. Once you've got a solution, The hard part is to implement it, change management, and keep it there as well.